Hi, I'm Joe Feeks, editor of Pig Health Today, and with me is Dr. Meggan Bandriick. She is a veterinarian and an immunologist at Zoetis. Meggan, thanks for joining us today.
Thanks for having me.
Veterinarians and producers throughout the pork industry depend heavily on vaccines, and they use them routinely. Maybe they even take them for granted sometimes, but I think every now and then, especially when a new product comes along, it's good to kind of pop the hood on these products and try to help the industry understand how they work. So what I wanted to talk with you today about is cell-mediated immunity, otherwise known as CMI. It's a mouthful for a lot of people, but to you as an immunologist, I'm hoping that maybe you can give us more perspective on the importance of that and what does it really mean?
Sure. So really there's two big branches of the immune system. There's the antibody branch, which a lot of people know about, a lot of people talk about antibodies. And then the other side is the CMI, or really it's T cells. They are really important. They're important in not only helping those B cells produce antibodies, but they're also the only type of immune cell that can actually kill an infected cell. So antibodies can't get inside of cells, but the T cells are the ones that can actually destroy infected cells.
So in any vaccine that you might use for whether it be PRRS or flu or circovirus, that they all operate the same way? They have a cell-mediated immunity function?
That's a great question. So it's important to consider the protective mechanism. Is that antibodies or is it T cells? But oftentimes it's both. So antibodies are important, but T cells are important too. And when you look at circovirus, both antibodies and T cells are important, but not all of our vaccines do a very good job inducing both antibodies and T cells.
So tell me how this actually works in practice. Now, your company, Zoetis, recently rolled out a new vaccine for porcine circovirus. It's got two genotypes in it, 2A and 2B, and that by itself is another story. But how does cell-mediated immunity come into play in the performance of a product like that?
When we're looking at circovirus, we know that both antibodies and T cells are important. And so we wanted to make a vaccine that induces both antibodies and T cells. And so what we've used to help boost the immune response or help direct the immune response is the adjuvant. And the adjuvant it's just that. It's something that helps direct and boost the immune response. And so our adjuvant that we use is Metastim. And Metastim induces both antibodies, but importantly, it induces T cells too. And if you look at some of the competitor products, many of them do a very good job of inducing a robust antibody response. But when we have compared the response in pigs to competitor vaccines and to our vaccine does a very nice job of inducing a robust T cell response in addition to a robust antibody response.
And what exactly do you see? How do you go about quantifying this? Because the science behind it sounds wonderful, but practically speaking, again, what does a veterinarian and producer need to understand about why this makes a better vaccine that'll provide broader coverage?
T cells are difficult to measure, right? So antibodies are pretty easy to measure. You can collect a blood sample, you can freeze that blood sample and then ship it and have the diagnostic lab measure your antibody levels. But for T cells, it's a bit more challenging actually to measure their function. And so what we do is we collect the T cells from the blood and we actually incubate those T cells along with PCV virus antigen. And what we can see is that T cells that have responded to the vaccine when the pig is vaccinated, those T cells respond in the lab in culture to the PCV2 virus antigen. And we can measure that response. We use something called an ELISpot. It's similar to an ELISA, and an ELISA is what's most often used to measure antibodies. But here we're looking at T cells that produce interferon gamma, which is a cytokine, in response to PCV2 stimulation. And when we put our vaccine and a competitor vaccine in in different pigs, but we isolate those lymphocytes, we can see a clear difference. our vaccine induces a very strong T-cell response, and the competitor only induced a very low response, and really it was only after challenge that we saw that T-cell response.
Interesting. So is the end result better efficacy, longer duration of immunity? What's the bottom line on this?
So when we look at T-cells, they are key in long-term immunity, and that's been demonstrated in the literature. So we know that the higher the peak response after vaccination, the longer that immune response to vaccination is going to last. And we also know that PCV is a persistent virus, so it lasts in the pig for a long time. Darren Madsen from Iowa State has said that you can find PCV2 after 190 days after an animal is infected. And so antibodies can do a good job to neutralize the virus, so that means that it can't infect a cell anymore. But for persistent viruses like PCV2, you need a T-cell response so that you can stop the production of more viruses within a cell. And so that's why T-cells are important, because they kill the infected cell.
This vaccine is unique in that it has the 2A genotype and the 2B. Most other vaccines, or all other vaccines, have either 2A or 2B. So this
That's right.
This is an industry first. So again, on paper, that sounds important, but from an immunologist's perspective, why is this important to have 2A and 2B together?
And that's a great question. It really is. And on one hand, we know that PCV2A and PCV2B and other strains, importantly PCV2D, are circulating within the swine population. So having PCV2B protection is important because PCV2B is circulating. But PCV2B is actually more closely related to PCV2D, the predominant strain, than A is to D. Not only are they more closely related, how the immune system actually recognizes B is more similar among B and D than A and D. And there's one more thing I want to talk about with that. Having two genotypes is actually of greater value than having a single vaccination with A or a single vaccination with B. And that's because PCV2 continues to evolve. And not only do we have point mutations, so single changes within the virus over time, but the PCV viruses can actually share genetic information. So recombination can happen. And so that means that the PCV2A viruses that we've seen in the early 2000s, they're different today. They have parts of PCV2B in them or PCV2D in them. So having two genotypes really gives us protection or broader coverage against the changing PCV2 viruses because of not only the point mutations, but because of those.
So it keeps mutating, it keeps changing, but you mentioned Dr. Darren Madsen of Iowa State. Looking at his latest surveillance data, we see that 2D is by far the most prevalent genotype out there. So it's great that you've got 2A and 2B, that's twice as much as anybody else has, but why not just go for the jugular, just go straight for 2D?
If it only took a couple of weeks or months to produce a vaccine, perhaps that's what we could do. But it actually takes multiple years from start to finish. So having a vaccine and an idea in your head to actually producing a vaccine and then having it be approved by the USDA. So we've been working on this project for multiple years. But I would say that if you look at the PCV viruses and how they're related to one another, there's really a cluster of PCV2A, and then there's a cluster of PCV2B and D. So they're very closely related. So having A and B really gives us representation from both of those clusters.
One other question I wanted to ask you is, in Greek mythology, there is this beast called a Chimaera. And as I understand it, it's got, I wish we had a picture, it was like the head of a lion and the body of a goat and the tail of a serpent, and a pretty ugly thing. But sometimes people use this same term, and they use a lot of Greek words, of course, in medical terminology, but they use the same term to describe vaccines that have been used in humans and also in animals, and I've heard the tag put on your vaccine as well. It sounds scary, but what does it mean?
It's actually pretty cool. Yeah. It's really innovative technology that we've been using. And what it really is it's taking the outer shell of the PCV virus from PCV2 and using the inner part of the virus from PCV1. And so having PCV1 and PCV2 together makes the Chimaera. But it actually is valuable to have PCV1, the inside of the virus, there. Okay. So let me explain that a little bit more. So most of the commercial vaccines only include the capsid, so only the PCV2 outside of the virus. And that's important because that's the immunodominant, or the part of the virus that the immune system recognizes the most. So it's important to have the capsid within your vaccine. But having the whole vaccine is it gives the pig a more authentic view, if you will, of the PCV2 virus. And so we have the PCV1 replicase, so the inside of the virus that allows it to replicate within our vaccine. And we've actually done some work to show that having PCV1 replicase can add to the coverage that we get from PCV2 field viruses.
So Meggan, you've made a great case for the Chimaera technology, but there are these other porcine circle virus vaccines out there, and they're working pretty well, and they're based on what's called a baculovirus. How does a baculovirus vaccine differ from what Zoetis has put together?
So we grow our Chimaera, so the PCV1/2 Chimaera, in pig cells, actually. And the baculovirus is an expression system. So what they do is they take the baculovirus, which is an insect virus, and they engineer it to produce the PCV2 capsid.
Yeah, let me get this straight. So it's based on an insect virus, and that's what's going into the pig.
So it's mainly the PCV2A capsid, but of course when you make the vaccine, portions of that virus or portions of the insect cells that the virus is grown in, they do wind up in the vaccine.
So, I mean, it certainly sounds better if your vaccine is built on pig cells instead of insect cells, but practically speaking, what does that mean? Does that have a measurable benefit?
It could be that the pig, of course, is not exposed to these insect cells or the insect viruses. And so the immune response, the pig's immune system sees the insect cell or insect cell debris, and that can result in a costly energy response because the immune system takes energy.
And when you say a costly energy response, meaning specifically?
The pig uses energy to respond to the vaccine and really everything that's in the vaccine. And so when we look at our vaccine, the pig responds to the PCV virus, and that immune response doesn't really recognize the pig cells that are part of the vaccine. Mm-hmm. On the other hand, for the baculovirus expressed vaccines, the pig also sees the PCV2A capsid, but it also sees some of that virus and some of the insect cell debris. And so that means that the pig's immune system is responding to some of that insect cell debris as well.
So it confuses it a bit, which then in turn saps the pig's energy, which maybe ultimately could compromise things like feed conversion or growth rate?
Potentially, but just as you said, those other vaccines work well too.
Well, Meggan, you've done a great job of kind of giving us a tour under the hood of the new vaccine and taking a very scientific subject and putting it in a language we can all understand, so I really appreciate it. We've been talking to Dr. Meggan Bandriick. She is a veterinarian and an immunologist at Zoetis. Again, Meggan, thank you for coming by.